NASA's Perseverance Rover, searching for signs of ancient life on Mars. NASA's Mars 2020 Perseverance Rover has begun its search for signs of ancient life on the red planet. Flexing its 7-foot 2-meter mechanical arm, the rover is testing the sensitive detectors it carries, capturing their first science readings. Along with analyzing rocks using X-rays and ultraviolet light, the six-wheeled scientist will zoom in for close-ups of tiny segments of rock surfaces that might show evidence of past microbial activity. Called PIXL, or Planetary Instrument for X-ray Lithochemistry, the rover's X-ray instrument delivered unexpectedly strong science results while it was still being tested, said Abigail Allwood, PIXL's principal investigator at NASA's Jet Propulsion Laboratory in Southern California. Located at the end of the arm, the lunchbox-size instrument fired its X-rays at a small calibration target, used to test instrument settings, aboard Perseverance, and was able to determine the composition of Martian dust clinging to the target. That's just a small taste of what PIXL, combined with the arm's other instruments, is expected to reveal as it zeroes in on promising geological features over the weeks and months ahead. Scientists say Jezero Crater was a crater lake billions of years ago, making it a choice landing site for Perseverance. The crater has long since dried out, and the rover is now picking its way across its red, broken floor. If life was there in Jezero Crater, the evidence of that life could be there, said Allwood, a key member of the Perseverance arm science team. To get a detailed profile of rock textures, contours, and composition, PIXL's maps of the chemicals throughout a rock can be combined with mineral maps produced by the SHERLOC instrument and its partner, Watson. SHERLOC, short for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, uses an ultraviolet laser to identify some of the minerals in the rock, while Watson takes close-up images that scientists can use to determine grain size, roundness, and texture, all of which can help determine how the rock was formed. Early Watson close-ups have already yielded a trove of data from Martian rocks, the scientists said, such as a variety of colors, sizes of grains in the sediment, and even the presence of cement between the grains. Such details can provide important clues about formation history, water flow, and ancient, potentially habitable Martian environments. And combined with those from PIXL, they can provide a broader environmental and even historical snapshot of Jezero Crater. What is the crater floor made out of? What were the conditions like on the crater floor? Asks Luther Beagle of JPL, SHERLOC's principal investigator. That does tell us a lot about the early days of Mars, and potentially how Mars formed. If we have an idea of what the history of Mars is like, we'll be able to understand the potential for finding evidence of life. While the rover has significant autonomous capabilities, such as driving itself across the Martian landscape, hundreds of Earthbound scientists are still involved in analyzing results and planning further investigations. There are almost 500 people on the science team, Beagle said. The number of participants in any given action by the rover is on the order of 100. It's great to see these scientists come to agreement in analyzing the clues, prioritizing each step, and putting together the pieces of the Jezero science puzzle. That will be critical when the Mars 2020 Perseverance rover collects its first samples for eventual return to Earth. They'll be sealed in super clean metallic tubes on the Martian surface so that a future mission could collect them and send back to the home planet for further analysis. Despite decades of investigation on the question of potential life, the red planet has stubbornly kept its secrets. Mars 2020, in my view, is the best opportunity we will have in our lifetime to address that question, said Kenneth Williford, the deputy project scientist for Perseverance. The geological details are critical, Allwood said, to place any indication of possible life in context, and to check scientists' ideas about how a second example of life's origin could come about. Any hunt for biosignatures will include the rover's suite of cameras, especially Mastcam Z, located on the rover's mast, which can zoom in to inspect scientifically interesting targets. The mission science team can task Perseverance's SuperCam instrument, also on the mast, to fire a laser at a promising target, generating a small plasma cloud that can be analyzed to help determine its chemical composition. If those data are intriguing enough, the team could command the rover's robotic arm to go in for a closer look. To do that, Perseverance will rely on one of two instruments on the turret at the end of its arm. PIXL, the Planetary Instrument for X-ray Lithochemistry, will employ its tiny but powerful X-ray beam to search for potential chemical fingerprints of past life. The SHERLOC, the Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, instrument has its own laser and can detect concentrations of organic molecules and minerals that have been formed in watery environments. Together, SHERLOC and PIXL will provide high-resolution maps of elements, minerals, and molecules in Martian rocks and sediments, enabling astrobiologists to assess their composition and determine the most promising cores to collect. An enduring hope of the science team is to find a surface feature that couldn't be attributed to anything other than ancient microbial life. One such feature could be something like a stromatolite. On Earth, stromatolites are wavy, rocky mounds formed long ago by microbial life along ancient shorelines and in other environments where metabolic energy and water were plentiful. Yes, there are certain shapes that form in rocks where it's extremely difficult to imagine an environment devoid of life that could cause that shape to form, said Williford. But that said, there are chemical or geologic mechanisms that can cause domed layered rocks like we typically think of as a stromatolite. Enter Perseverance's sample caching system. The steamer trunk-size collection of motors, planetary gearboxes, and sensors is among the most complex, capable, and cleanest mechanisms ever sent into space. With it, the science team will collect the most intriguing samples they can find, store them in samples tubes, and, later, deposit them, so that future missions can collect the sample tubes and fly them back to Earth for analysis. The instrumentation required to definitively prove microbial life once existed on Mars is too large and complex to bring to Mars, said Bobby Braun, the Mars Sample Return Program Manager at JPL. That is why NASA is partnering with the European Space Agency on a multi-mission effort, called Mars Sample Return, to retrieve the samples Perseverance collects and bring them back to Earth for study in laboratories across the globe. And when that happens, samples from Mars Perseverance Rover may tell us that at one time billions of years ago life existed elsewhere in the universe, but they also may indicate the opposite. We have strong evidence that Jezero crater once had the ingredients for life. Even if we conclude after return sample analysis that the lake was uninhabited, we will have learned something important about the reach of life in the cosmos, said Williford. Whether or not Mars was ever a living planet, it's essential to understand how rocky planets like ours form and evolve. Combined with other instruments on the rover, the detectors on the arm, including SHERLOC and Watson, could make humanity's first discovery of life beyond Earth. A key objective for Perseverance's mission on Mars is astrobiology, including the search for signs of ancient microbial life. The rover will characterize the planet's geology and past climate, pave the way for human exploration of the red planet, and be the first mission to collect and cache Martian rock and regolith, broken rock and dust. Subsequent NASA missions, in cooperation with ESA, European Space Agency, would send spacecraft to Mars to collect these sealed samples from the surface and return them to Earth for in-depth analysis. The Mars 2020 Perseverance mission is part of NASA's Moon to Mars exploration approach, which includes Artemis missions to the Moon that will help prepare for human exploration of the red planet. JPL, which is managed for NASA by Caltech in Pasadena, California, built and manages operations of the Perseverance rover. Like, comment, share and subscribe to my channel.